Alright, this is section 3.2 from Algebra 2. It's really I'm going to break 3.2 up into two different sections. First thing we're going to talk about is solving systems by substitution. 3.2 also talks about elimination. I'll talk about that in another video. So today our objective is going to be to understand how to solve a system of equations by substitution. So we're going to find the intersection point. Remember, that's what the solution is, where those two lines hit on the graph. So we already did solving by graphing. If you guys need more work on that, go ahead and watch the previous video that we did. Right now we're going to talk about another way to solve these, and it's called substitution. So if you guys look in both equations, remember it's where our x value and our y value are both the same. So if I know an x value or a y value for either equation, I can plug it in to find the rest of my solution, which is really the other value I don't have. So if you guys look here, I know what the x value is in my second equation because x equals this whole thing over on this side. So I can go back to my first equation in my system and I can plug this whole thing in there. Really, I can substitute it in. So I'll show you what I mean here. What I mean when I'm substituting is I'm going to take that 4 and I'm going to plug in this whole piece with my x equals, well, the whole x equals negative 5y minus 9. I'm going to plug that whole piece in for x now, plus 3y equals negative 2. And the reason we do that is you can look at this equation I have now that I've written. I only have one variable, and I can solve from there. So I need to distribute through to each piece here, so I'm going to get negative 20y minus 36 plus 3y equals negative 2. Now we can go ahead and we can do some changing around, combining of like terms, and I'm going to add the 36 over onto the other side as well at the same time. So I'm going to get negative 17y equals 34. Now you can see we only have one more step to do. We have to divide by negative 17 to get y by itself. So y is going to equal negative 2. Now the biggest mistake I would say in this section is going to be stopping right there and saying you have a solution. But remember, a solution isn't one part of a point. It's not one number, it's a whole point. So that means I need an x value and I need a y value. So now I need to take this y that I know works for both of them and I'm going to plug it in for the x, where x equals negative 5 times negative 2 minus 9. And I can really plug it in for either equation, but I'm just going to pick the easier one. Now we're going to plug this in, or I should say solve it. So 10 minus 9, so x equals 1. Now, depending on your teacher, how they want you to do it, they might be fine with you leaving it like this. I want you to write it as a coordinate pair because you're finding a solution, so write it as a solution. You're finding the point of intersection, so write it as a point. And the way we write a point, remember, is we just take our x value, 1, and our y value, negative 2, plug it into a coordinate pair, and there's my solution. This is my solution to this system. Now you should always check your guys' answer, so I'm going to do that really quick and I'm going to plug those in and find out if it actually does indeed work. So 4 times 1 plus 3 times negative 2, does that equal question mark negative 2? So 4, really this is minus 6, does that equal negative 2? Well, yeah, negative 2 definitely equals negative 2. That works. Alright, I'm going to check it with this one now quick. So does 1 equal negative 5 times negative 2 minus 9? Well, we already figured that one out because that's the one we plugged it into. But I'll keep going anyways. 10 minus 9, which 1 does equal 1. Sorry, I should have put my question marks. So that's how you solve using substitution. Now, when you're using substitution, it's not always going to look quite as easy as that first one. We're not always going to have an x equals or a y equals. We might have to change the equation around to get it so we have an x equals or a y equals. Now we have two equations up here. One's really definitely easier to see that we can change it around. I'm going to move this over. I'm going to move the y over so I get x equals a number. So I'm going to add y to both sides. So x equals y plus 4. Now again, I have an x equals here. So I know what my x is here. So I can plug it in for my x down here. I'm going to plug this whole piece in down here. So again, we're going to get negative 6 times y plus 4, and that's going, or keep going, plus 6y equals negative 24. So we plugged it in for the whole equation there. we plugged the entire piece of that equation in for x over there. Now we're going to distribute through each piece, so negative 6y minus 24 plus 6y equals negative 24. Now if you guys notice, what's going to happen here, our negative 6y plus 6y cancel out, so we're left with negative 24 equals negative 24. Now I want you guys to think about something. When does negative 24 equal negative 24? Well, it always equals 24, or negative 24, right? So this tells you right away that there's infinite solutions. And really, that tells you also that the lines are the same. They're the same line. That means they're consistent and dependent on each other. Whereas the previous one that we did down here, this one only had one solution, so it was consistent, but it was dependent. All right, I want you guys to try this one. I want you to pause, try it on your own. I'll show you guys the answer in 1 second. All right, here's the solution I got. Again, it's one solution, so that means they intersect only one time. Let's try some more examples here. I'm going to pause it, and I want you guys to try these on your own. We're going to try, or I'll put the answers up in 1 sec again. Please try both problems, see what you get. So here's what I got showing my work. Check it, pause it if you need to. Here's the first solution, and here's the second solution. All right, we only have one more thing I want to go over. I want to go over word problems. So the Armstrong Falcon fans bought 5 times as many tickets as the visiting Cooper Hawk fans for the Friday night basketball game. The total number of tickets sold was 1,440. How many tickets did the Falcons buy? Well, the first thing we really need to do is we need to make some variables. So we can name our own variables. Now, I personally chose some, and I'm going to choose F. That's going to equal the number of Falcons fans. And we're going to do C is going to equal the number of Cooper fans. I know it's brain teaser why I use those variables, but those are the variables we're going to use. Now we have to think about is, how do we write these equations? Well, the first sentence gives something away. The Armstrong Falcons fans bought 5 times as many tickets as the Cooper fans. So we know that F is going to equal 5 times C, which is the number of Cooper fans. Now we also know that the number of tickets added together is going to equal 1,444. So the equation is simply F plus C, and that equals 1,444. Now again, let's use substitution to solve this system of equations. So let's use substitution to solve this. We know that the Falcons equals 5 times C, and F plus C equals 1440. So all we have to do is plug in the F for the F. So now we know that 5C plus C equals 1440. And we could take this up here, and we realize that 5C plus C is 6C equals 1440, which we divide by 6, and we get C equals 240. Now we have to do is plug that back into for C over here. So F is going to equal 5 times 240, which means F is going to equal 1,200. So really, that doesn't answer our question, though. If we come up to somebody and say, well, F equals 1,200, C equals 240, they're going to look at you like you are speaking gibberish to them. It's just... So let's actually answer the question here. So there were 1,200 Falcon students. So there were 1,200 Falcons, and there were 240 Hawks at the game. That's all we're going to talk about in this first section. Next section we're going to talk about is solving systems using elimination.